The RIDGID NaviTrack line transmitter is a device that generates radio frequency signals. When these signals are applied to buried metallic conductors, such as gas, electric, phone, and other utility lines, technicians can use compatible receivers, like the RIDGID NaviTrack cable pipe and sond locator, to locate and mark a utility's position underground. The transmitter's 5 frequencies range from 512 Hz all the way up to 200 kHz to accommodate a wide variety of situations. The coiled connection leads extend up to 25 feet each, making it easy to reach distant connection points, and use a combination of copper and aircraft-grade stainless steel for the ultimate in signal transmission and durability. The sturdy ground spike stores right on the case, so it's always there when you need it, and has a molded grip that's easy on your hands. An inductive clamp, which can be ordered separately, makes it easy to apply signals to lines with inaccessible conductors. Contact your RIDGID dealer for details on purchasing. The transmitter also includes a user's manual, batteries, and this video. This video will help familiarize you with the equipment so you can get up and running quickly, but does not cover locating theory, technique, best practices, or safety, so be sure to read the manual for additional instructions and important safety information not covered in this video. If you're new to locating, training is available from third-party vendors and is recommended before using any locating equipment. In this segment, we'll cover the basics of setting up and operating the transmitter. We'll show you how to install the batteries and demonstrate the 3 methods of getting a signal onto the line. The transmitter operates on 8 D-sized batteries. To install the batteries, locate the battery compartment on the rear of the transmitter and turn the locking knob a half turn to release the battery holder. Install the batteries with the correct polarity as shown on the battery holder. High-quality alkaline batteries can last up to 12 hours, depending on usage and environmental factors. Rechargeable batteries can also be used, but to prevent damage to the batteries or to the unit, do not mix rechargeable and standard battery types. When you're done, slide the holder back into the transmitter and turn the locking knob a half turn to secure it. Press the power button to make sure the batteries are good and that they've been installed correctly. Now that the transmitter is operational, let's look at getting a signal onto the line. There are 3 ways of applying a signal to the line with your NaviTrack transmitter: direct connect using the transmitter's leads, inductive using the optional clamp, and inductive using the coil built into the transmitter housing. With direct connect, one lead is clipped to an exposed metal portion of the utility, and the other is clipped to the ground stake. This forms a complete circuit that the signal can travel through. Direct connect is the preferred method of applying a signal because it gives you the strongest signal and lets you use lower frequencies, which travel farther and are less prone to bleed over onto nearby non-target conductors. Use direct connect whenever you can safely clip the transmitter's leads onto a metallic utility or to the tracing wire for a non-metallic utility. Direct connect is commonly used on gas, electric, phone, water, cable, and fiber optic lines. To use the direct connect method, remove the ground stake from the bottom of the transmitter and drive it as far into the earth as possible. Connect one of the transmitter's leads to the ground stake and connect the other lead to the utility you'll be tracing. Turn the power on and select the desired frequency. The steady beeping sound indicates that the transmitter has a good low-resistance connection that will allow plenty of signal to get onto the line. The inductive clamp is an alternate method of applying a signal that's often used when the metal portion of a conductor is inaccessible, or when connecting directly to it could be hazardous. The clamp plugs into a jack on the transmitter, and its jaws are clamped around the utility. When the transmitter is turned on, the signal radiating from the clamp induces a signal onto the utility. The inductive clamp is commonly used on electric, phone, cable, and fiber optic lines, but is considered less desirable than connecting directly because it only works with frequencies of 33 kHz or higher, which generally don't travel as far and are more subject to bleed over than lower frequencies. Also, both ends of the target conductor must be grounded in order to get a signal to flow on the line. To use the inductive clamp, Insert its plug into the jack on the back of the transmitter, and clamp its jaws around the target utility. Turn the power on, and select one of the 3 upper frequencies. Because the 2 lowest frequencies are not suitable for inductive locating, you will not be able to select them. The clamp's handle has 2 LEDs to help you diagnose its connection status. When one LED is lit, the clamp is receiving the transmitter's signal, but the jaws are not fully closed, which means no signal is being applied to the target conductor. It's important to make sure that both LEDs are lit, otherwise you are not applying a signal to the line. The inductive coil acts as a broadcast antenna, transmitting a signal that induces a current onto nearby conductors. The inductive coil works with most lines, but is normally reserved for situations where the target line is completely inaccessible and there is no other means of inducing a signal. That's because it induces a signal onto all conductors in the area, which can make it difficult to accurately trace the target utility. The inductive coil only works with frequencies of 33 kHz or higher, which generally don't travel as far and are more subject to signal bleed than lower frequencies. Also, both ends of the target conductor must be grounded in order to get a signal to flow on the line. For inductive locates, align the transmitter lengthwise across the buried line as shown in the diagram on the keypad. Turn the power on, select one of the 3 highest frequencies, then press the frequency button again to switch the transmitter to inductive mode. When the transmitter is in inductive mode, the inductive mode LED on the keypad will be lit. To switch out of inductive mode, press the frequency button again. Inductive mode only works at the 3 highest frequencies, so you will not be able to select inductive mode with the 2 lowest frequencies. The inductive coil transmits a powerful signal, so you'll need to begin your locate at least 40 feet from the transmitter to minimize the effect of air coupling between the transmitter and the receiver's antennas. Now that you've seen the basics of setting up and operating the transmitter, let's take a look at some tips that can help you be more productive. The frequency you choose can have a large impact on your locate. In general, low frequencies are preferred because they travel farther and are less prone to bleed onto non-target utilities. On the other hand, high frequencies can often jump across corroded or electrically isolated pipe joints that would stop lower frequencies. They also produce a stronger signal than lower frequencies when the resistance of your circuit is high. The resistance of your connections can affect the strength of the signal you're tracing. Low resistance connections produce stronger signals that are easier to locate. Here are some ways you can lower the resistance of your connections. Scrape the connection point to make sure it's free from paint, dirt, and grime. When you attach the transmitter's leads, work their teeth into the metal to ensure that good contact is being made. Hard, dry dirt at your grounding point can also raise the resistance. If an alternate grounding point is unavailable, wetting the soil can significantly lower the resistance of your ground. If you are unable to lower the resistance of your circuit, choosing a higher frequency may give you a stronger signal. Signals radiating from non-target conductors can interfere with the signal on the target conductor and decrease the accuracy of your locate. There are several ways this can happen. If the ground spike is placed too close to a non-target conductor, the signal may bleed onto it. To avoid this, be sure to ground away from non-target conductors. If you need to stretch out the transmitter's leads to reach a distant connection point, keep them away from the line you're trying to locate, otherwise the signal radiating from them can pull you off the target utility. The signal radiating from the target utility can bleed over onto nearby conductors. High frequencies tend to bleed over more than lower frequencies, so use the lowest frequency possible to minimize this effect. If 2 or more utilities share the same grounding point, such as a water line, the signal applied to one utility will often get onto the other utilities as well. To help prevent this, isolate the target conductor by disconnecting or unbonding its ground. Working with electricity can be hazardous, so seek qualified help if you are unfamiliar with how to do this. Let's take a moment to review what you learned. A complete circuit is required in order for signal to flow through the target utility. If your signal output is low, improve your connections to lower the resistance. Place the leads in a manner that reduces the potential for interference. When using the inductive clamp, both LEDs must be lit or you are not applying a signal to the line, and both ends of the target conductor must be grounded. Begin Inductive locates at least 40 feet from the transmitter to avoid air coupling between the transmitter and the receiver's antennas. And remember that the signal energizes all nearby lines, which increases the potential for interference. In the past few minutes, we've introduced you to the NaviTrack transmitter. We've showed you how to set it up and operate its features, and we've given you some tips that will help you use the unit more effectively. Before using the transmitter, be sure to read the operator's manual. The operator's manual contains detailed information on the equipment's features and operation, and will help you get the most out of your equipment. From all of us at RIDGID, thank you for buying the NaviTrack line transmitter, and thank you for watching this video.